Hello. Today we're going to learn how to compare decimals using base 10 blocks. We've already done this activity in the classroom, but I thought that watching the video would help reinforce what you learned. Please pay close attention.
Okay guys, remember when we worked with base 10 blocks before and worked with whole numbers and we used them on the desk and we were building different things? Who remembers what this was referred to as? This is known as a what?
A cube.
It's a cube, small cube. What would this be worth?
One.
One, good. What about this one? What was this worth?
10.
Okay. What about the flat?
100.
What about this big one?
1,000.
1,000. And for today's lesson, we're going to approach and look at ways we can use these with decimals. So one of the things I want to talk about is we're going to refer to this as the small cube. This is going to be referred to as a long. This is referred to as a flat. And this one we'll use as large cube. Okay? Okay guys, we're going to start with the flat today. And we're going to, if this is our whole, this is our value of 1, what would this be with this whole? Mace?
1/10.
1/10 of it? Okay. Mason, what makes you think that this is 1/10?
Well, because it takes 10 of those to equal one flat.
Excellent. What about this? What about the cube? The small cube. Allison, what would this cube be worth, a small cube?
100th.
100th. Good. And how many of these would it take to fill up our whole, our flat?
100.
100 of them. Great. Now, if this is worth 1, what would this be worth? Jacob?
10.
10. Why?
Because 10 times 1 equals 10.
What's the relationship between these two? Mason?
Because it takes 10 of those flats to equal the one big cube.
Great. Excellent. Excellent. Okay. Any questions on that? Does that help you?
Yeah.
Okay. Delaney? Allison? Okay. Okay, guys, if this is the value of 1 this time, this is 1. This represents the 1. What would be this? What would be the value of this?
1/10.
1/10. Why? Why is this
Because
1/10?
it takes 10 of those to equal one big cube.
Super. Super. What about this? This would be what? Allison?
100th.
Why?
Because it takes 100 of those to make the big cube.
Okay. What about this little guy, small cube? What do you think on this, Jacob?
That would be 1,000th because it takes 1,000 of those to make a cube.
That'd be pretty cool, huh? All right, guys, for the next activity, I want to go over that this will always be the value of 1. In that case, what would this be? Delaney?
1/10.
Great. What would this be? Allison?
1/100th.
100th. Good. What would this be?
10.
10. Excellent. All right. The next thing I want to do is get you guys looking at these, and we're going to compare and make some decimals, remembering that this is always going to be our whole, or our 1. Show me 1 64/100ths. What do you think that would look like? Show me. 1 whole, and then 60, and then 400ths. So how many tenths would you need to represent 60? Allison?
6.
6. And how many hundredths would you need to represent 400ths? Jacob?
4.
4. So do you see that you have 1 whole and 60 or 6/10 and 400ths, all right? Now, I also want you to build for me 1 68/100ths. So you have 1 64/100ths and 1 68/100ths. What can you tell me? Look at these. Compare these a little bit. What's something that they all have in common? Jacob?
They each have 6/10.
They each have 6/10. What else is in common with them? What else do they all share and have in common? Looking at them. Look at the whole. Do they share something in common with the whole?
They each have 1 whole.
They each have 1 whole. Good. And what about the hundredths? Do they each have the same amount of hundredths?
No.
No. So if you were going to compare these two together, what can you tell me about them? Look at your 1 and 68 hundredths. Look at your 1 and 64 hundredths. What do you notice?
1 and 68 hundredths is greater than 1 and 64 hundredths.
Super. Do you all see that? Can you all see that building with the blocks here? Great, great. Any questions? Okay, let's go ahead and clear this off and set those aside. Now I'm going to ask you to try something else for me. And we're going to, again, compare these two. What I would like you to do is show me 3/10. Remember, we're still using this as our whole, but I just want you to show me 3/10. Okay. Is that a whole? No, it's not. So we don't have a whole number here, do we? Show me 9 hundredths. What would 9 hundredths look like? 9 hundredths. Okay. So, and keep your 3/10 there, because we're still I want you to compare. Remember, we're comparing. So what, if you compare these back and forth, what can you tell me about those? Mason.
3/10 is greater than 9 100ths.
Why?
Because if they can't equal 10, because these take 10 to equal one of these, and they have 3, and this they only have 9 in here.
Do you agree with that? Think? Yeah. Okay. Any questions on that? All right, super. All right, let's go ahead and clear that for a second. Now I'm going to have you build again for me. This time I would like you to show me 2 and 78 hundredths. And keeping that there, the next thing I'd like you to show me is 2, again, and 9/10. Now, who could tell me, how did you represent 2 and 78 hundredths?
I took 2 wholes and 7/10 and 8 hundredths.
Super. And how did you represent, Jacob, 2 and 9/10?
I took 2 of the ones and 9 of the tenths.
Good. Okay. Now, look at them both. Compare them. Which one would be greater? And how do you know? What do you think, Jacob?
2 and 9/10.
Why?
Because both of them have 2, but if the second number is greater than the other one's second number, the one with the greater second number is bigger.
Okay. Anybody have a different way of saying it? What were you going to say, Mason?
Basically, it's just the same thing. It's just worded a little bit different.
Go ahead. What would that be?
2 and 9/10 are greater than 2 and 78 hundredths, because it was basically the same, because 9 is greater than the 7/10.
Okay. Do you all see that? Does this make it easier for you guys to see, to compare these decimals using these blocks?
Yes.
Why does it make it easier? Mason?
You can actually see them.
You can actually see them, and you can use the blocks to help you tell the difference if one's greater or lesser than the other. Would you agree with that? Okay, super. All right, guys.
I hope this video helped you learn how to compare decimals using the base 10 blocks.